Now in this video we'll go through the chapter 3.2 activities to help explain the idea of commutative and associative property. Now with the commutative property, remember commutative allows us to flip the order of addition problems. So for example, in this first problem, adding 7,999 plus 857 is hard, but if I flip these two using the commutative property, 7,999 plus 1 is much easier to do. So now I have 8,857. So I use the commutative property to make that an easier problem to do. Because I flipped the order, and I can only do this with addition as well as multiplication. Now, when I look at number 2, the easiest thing here is, since it's addition, is to group those last two numbers together. That's associating them together. So what I'm doing is using the associative property to make that a much easier number to work with. So here is the associative. Now 100 plus 367, much easier to solve to get 467. Now the next one, again, 153 plus 19, yeah, I can do that, but if I flip these two numbers around, 153 plus 7, much easier to deal with. So using the commutative property again. So that's 160, and 160 plus 19, that's very much easier to add as well. Gives me 179. And this final one, again, the last two, if I group them, thinking about money, I had 5 cents to 95 cents. That takes me up to a whole dollar. So now I'm looking at 7 and 89 hundredths plus 7. That's much easier thanks to the associative property to solve. So it's not that it's necessary to flip the problems around, but it makes the problems easier to solve, knowing that we have these properties that can help us. Now, we can also take a problem that is just, say, two numbers and split it into something that may be a little bit easier for us to solve, as long as we remember that whatever we add, we always subtract, or whatever we subtract, we always add back. For example, if I look at this number here, 99 is kind of hard to deal with, but 99, I could say, is the same thing as 100 minus 1. So I'm going to split it apart. That's a much easier problem because 183 plus 100 gives me 283. 283 minus 1, 282. So we're using some mental math to help us solve this problem. Now the next one, 268 plus 52. Well, I could say that that's 268 plus 2 plus 50. Split it into something that's easier, because 268 plus 2 takes me to 270, and 270 plus 50 would take me to 320. It's not that it's necessary, but again, it's an idea of trying to make the problem maybe a little bit easier to solve. And there's other ways you could have done it. You could also split 268 up to 250 plus 18 plus 2 plus 50. And then you've got the 250 plus 50 to get you to 300. 18 plus 2 is 20, so 320. Again, different ways, trying to make the numbers maybe a little bit easier to deal with. Now, when I'm looking at 600 minus 199, this is one where people will make mistakes when they try to go about the mental math of it. And here's why. If I think about what I want to do, the idea is I'm going to increase 199 to 200. If I remember, that's one more than where I started. However, where people make their mistake is that they forget to distribute that negative to both terms. So what I'm really looking at is 600 minus 200 plus 1, because a negative times a negative gives me a positive. 400 plus 1 gives me 401. Same thing with the next one. What may be easier to do would be to say, okay, if I can get the first number up to 170, then I'm doing 170 minus 70. So if I look at this, I could say that's 170. Well, that was 6 too many, so that's 170 minus 6 minus 70. Now, if you think back to some of your earlier algebra, you can also think about this as if it's a negative number that we're dealing with. So I could flip these around. This is the same thing as saying negative 6 plus 170 minus 70. And then I could use the associative property to say that I'm looking at negative 6 plus 100, which would get me to 94. So if you add the 6, you just have to remember to remove the 6 at the end. Or if you remove 1, you need to remember to add 1 at the end. And the subtraction can sometimes throw people off. Now here, 999 plus 9,999, not so easy, but that's the same thing as 1,000 minus 1. And this is the same as 10,000 minus 1. Now I could then rewrite this to say that this is 1,000 plus a negative 1 plus 10,000 plus a negative 1, which allows me then to use the commutative property, or because I can flip the negative 1 into 10,000. So it's 1,000 plus 10,000 plus negative 1 plus negative 1. So 11,000 plus my two negative 1s, and I could use the associative property to group them together and say that's plus negative 2 to get me to 10,998. Now last one, again, adding all 99 cents, kind of hard, but I could say that's $3, this is $4, this is $2, and this is $5. And I could add those relatively easily. 3 plus 4 is 7, 7 plus 2 is 9, 9 plus 5 is 14. But what I have to remember is I added 1 penny to each of these, so I need to remember to subtract 4 cents or 4 hundredths at the end, which will leave me with 13 and 96 hundredths, or $13.96. Something very common you see in when you're shopping, for them to use 99 cents as a way to make it feel like it's less than the whole dollar. Now our last activity here was to have you examine what is it that, if we look at this problem, that Ramirez is doing. So Ramirez says he can calculate 253 minus 99 by adding 1 to both numbers and calculating 254 minus 100. And the question is this correct? Now if I pull out a calculator and I do 254 minus 100, I will end up with 154. If I do 253 minus 99, I still end up with 154. Now what is happening? Why would that work? If I think about writing out what I just did, 253 plus 1 minus 99 plus 1. Now we said earlier, well, if I add 1, I always have to take 1 away. But this is where you have to pay attention to our negative sign. The first one is a positive 1. The second one, because it's minus a positive, is a negative 1. So those two 1s technically cancel each other because of the minus in between. Because you have to remember that that negative gets distributed to both terms. So it is really a negative 1. So the idea that I can just add 1 to both terms is valid because the two negatives technically cancel each other out. Now if I look at his problem down here, what I would expect is, since he's saying, oh, this is 98, well, how many does it take to get up to 100? It takes 2 more. So what I would expect it to do would be to take 324, add 2 to the first term, take 98, add 2 to the second term. And again, that works because the first 2 is positive. The second 2, when I distribute that negative, is really a negative 2.